All right, so we're going to get started with chapter 3. So again, we're doing chapter 3 because it's some general information, not specific to chemistry, that we kind of need to get out of the way first. And so I would do this before I would do chapter 2, and that's why we're doing it before chapter 2. So this is all about scientific measurement. And so we have to have some ideas of how to work with numbers and units before we can get into anything else in this book. So we've got the objectives for the chapter. So chapter 3, scientific measurement, we got 3 sections. Each of them has a set of objectives that you should be able to do before you get to the test. So you've got one test under your belt at this point, so you have an idea of what a test in chemistry looks like. And you know that hopefully you did pretty well because you prepared yourself. So this is one of the things you can use to prepare yourself. So you've got write numbers in scientific notation. You should be able to do that before we get to the next test, or evaluate accuracy and precision, and so on and so forth. And we're going to learn how to do all of that here. So in this part, we're just going to go through a little bit about measurements and scientific notation. Right? So we know a measurement has 2 things to it. It's got a number and it has a unit. Okay? So the number, we're going to talk a lot about how we're going to write that number and how many digits of that number are important and all that kind of stuff. But it also has a unit, which means that we can't have naked numbers. Right? It's just indecent. We can't do things like that. We need to have a unit on the end of every number that we're going to work with. This isn't math class. And that means that when we work with numbers, it's not just the number that's important. So one of the things that we have to kind of get through in our heads is that when we work with numbers that are really big or really small, there is a different way to write them. We call it scientific notation, but really it's used anywhere that you're working with really big or really small numbers. And in chemistry, we do both a lot. We work with really big and really small numbers. And so we need a much better way of writing numbers out than to have to write them out the normal way that everybody else writes numbers. Okay? So what we're going to do here is we're going to replace decimal places with a power of 10. So that means that instead of having to write a whole bunch of places in your number, you can shorten the number greatly and then just let somebody know how many places did you just move that decimal point. So there's always 2 parts of scientific notation. Always consists of a number between 1 and 10. It's really important. It has to be between 1 and 10, not 10, but before you get to 10. And it's got to be greater than 1. So it can't be less than 1. And then there's a power of 10 to represent the decimal places. So we'll do an example. I'll show you how this is done. So if we want to convert a regular number into a scientific notation version of the number, the first step is to move that decimal point. So here's an example. Okay? So here's the number 1,000, and I want to write this in scientific notation. So I'm going to find the decimal point in this number first. Now, when we write out a number like this, the decimal point is there. We just don't see it, but we know it's there. It would be right here. Okay? So we're going to take that decimal point. We're going to move it over so that we make this into a number between 1 and 10. So if we move it over to here, then it becomes 100. And we move it over to here, it becomes 10. And like I said before, we can't have it at 10. We have to have it less than 10. So if I move it one more, and I move it right here, this becomes the number 1. Now, all I need to do is just make sure I keep track of how many places I just moved it. That's my powers of 10. So the number of decimal places moved is the power of 10. So I just moved it 3 places. So this is going to be 1 times 10 to the 3rd power. Right? And because every decimal place you move is a power of 10. That's what those mean. And so that's what we're just letting somebody know about this. Now, how do I know that it's going to be a positive 3? If this original number was larger than 1, then it's a positive power of 10. It's a negative power of 10 if the original number was smaller than 1. And we'll do some examples of both of those. Okay? All right, so let's try this one then. And please make sure that anytime you want to try something, you're pausing, or if I go too fast, you're pausing this video as you go. One of the advantages of having this on record is that if I'm talking to you in class right now, there's no pause unless you raise your hand and like tell me to slow down or you ask a question. But right now you can just pause anytime you want to. All right, so we have the number 10,000. So I'm going to pull out my pen here. And let's say the decimal point would be right here, of course. And I'm going to move that over so this is a number between 1 and 10. So here, here, here. I got to move it all the way to here before I get a number between 1 and 10. So I get the number 1. And I just moved it 4 spots. So times 10 to the 4th power, right? It's that easy. That's all we're doing here. But it's a little bit simpler than having to write 1 with 4 zeros after it. Because first of all, you don't have to write all those zeros. And then when somebody wants to read that number, they can quickly see that it was supposed to have 4 zeros in it instead of having to look and count them in their head. I mean, if you wanted to know that that was the number 10,000, you would, and you probably do this very quickly in your head, but you'd have to know how many zeros are there. Well, this tells you really quickly. There's 4 of them. All right, let's try another one. There's the answer. So the next one, let's try a number smaller than 1. We're going to do the same process. Here is the decimal point. So I'm going to move the decimal point over. So this is a number between 1 and 10. That doesn't work. That doesn't work. That doesn't work. But if I move it here, this becomes the number 2. Right? And I just moved it 1, 2, 3, 4 spots. So once again, 10 to the 4th, but it's not going to be positive 4th because this number was smaller than 1. So I have to let somebody know that this was a small number, so I'm going to use 10 to the negative 4th as the answer here. All right? Well, let's see if you can do it. So I'm going to give you 2 more examples here, and then I want you to pause, and I want you to try to do those 2 on your own paper while you're writing your notes here. And then you can unpause, start the video again, and see how you did. All right? So here are the 2 examples. You've got this one and this one. Okay? So pause, and then I want you to try and do those on your own and then come back. All right, so let's go through the answers. So in this number, right, this is a really big number. So way down here is where the decimal point currently is. And I have to move this all the way over so that it's a number between 1 and 10. So I got to move it here, 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 all the way there, right? Because that number, the number is just a little over 5. If I stop here, it's 59. If I stop here, it's 596. I have to go all the way to here. So this is 5 point. Now, before, I just left all those zeros off. Okay, I left all those zeros off because zeros aren't a big deal. You can assume that zeros are there. But when I have numbers that are not zeros, I have to write them. So I'm going to write the 9 and the 6 and the 0, 1, 1. I can, assume those last 3 zeros aren't a big deal. But I got to write all of those numbers, and then I got to let somebody know how many total places did I just move. So I just moved this 1, 2, 3, 4, 5, 6, 7, 8 places. And I know it's 10 to the positive 8th power because this number is way bigger than 1. All right? Okay, so let's try this other one here. We've got the decimal point right here. I'm going to have to move it 1, 2, 3 spots. If I move it right here, this becomes a number between 1 and 10. It's not quite 10 yet. Really close, but it's not quite 10. It's 9.9214. I just moved it 3 spots, so times 10 to the negative 3rd because this number is smaller than 1. Right? Okay. Now, we have to be able to go the other way too. Okay? We also have to be able to take a number that's in scientific notation, and we have to understand, how do you write that number as a regular number? Or at the very least, how do you read that in your head so you know what number that really is? So if somebody were to say 5 times 10 to the 6th, do you know what number that really is? So we're going to expand that back out. So this is 5 with 6 zeros. So 5 with 1, 2, 3, 4, 5, 6 zeros. Or in other words, 5 million. Okay. Let's try another one. 8.9 times 10 to the negative 7th. Right? What do we do with this decimal point here? Well, I have to move it 7 places, but I want to make this number smaller than 1. So I'm going to move it back this direction. So here's 1, 2, 3, 4, 5, 6, 7 places. So notice that's going to take my decimal point all the way back, and then I'm going to have 1, 2, 3, 4, 5, 6, 7 places, and then I still have that 9. Now, oftentimes I like to put a 0 in front of that decimal point. Just, it makes the decimal point stand out better. So you can definitely tell there was supposed to be a decimal point, just in case you don't press hard enough, you don't see the decimal point very well. You certainly don't have to do that, but I'm going to do it a lot, so you're going to see that a lot. But that doesn't count towards one of my moves, because I didn't have to move it past that 0. Okay? So once again, I want you to try a couple of these. I'm going to give you 2 more. There's 2 more examples. I want you to try both of these on your own. Pause it, come back, I'll show you the answer. Okay, so we've got 1.3315 times 10 to the 0. Times 10 to the 0. Well, 0 means 0 places you're moving the decimal point. So this is 1.3315. No movement necessary. That's just the number it is. The other way you can remember this is that you know that anything to the 0 power is 1. So 10 to the 0 power is just 1. So 1.3315 times 1 is just 1.3315. All right. The other one here is 3.33 times 10 to the negative 12th. Now, that means that this decimal point has to be moved 12 spots, and it's going to be smaller than 1. So this is going to go smaller than 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So I've got 12 spaces I'm moving this. So I'm going to take and put 11 zeros here. 3, 4, 5, 6, 7, 8, 9, 10, 11. 3 makes the 12th place, and then there's the other 2 3s. And that's that number. Now this is a perfect example to show you why we use the scientific notation. Nobody in their right mind wants to write a number or read a number like that. It might be a number that we have to use at some point, but it's certainly not a number we want to write like that. So writing it as 3.33 times 10 to the negative 12th at least gives you a really quick idea of what the size of that number is without having to write or read all of those zeros. Okay? So that's the main purpose of scientific notation. Now, we have scientific notation that we have to work with in our calculators. That, as I said just a few minutes ago, okay, calculators are, this class isn't math class, so I'm going to let you use calculators. I'm not looking for you to have to do a whole bunch of math in your head or on paper. I want you to be able to use your calculators to figure out what the answers are to some of these problems. And when we use scientific notation on the calculator, there are some things that we have to keep in mind. One of them is that on most calculators, there is a special button used for scientific notation. And I'm not even going to say most, right? It's really all. Okay? Every scientific calculator that's out there has a special button for scientific notation. That's one of the whole purposes of a scientific calculator, and so you can work with numbers like this. So, whatever calculator you're using, okay, and these days I don't have any clue. You might be using a regular old scientific calculator like a TI or a Casio, or you might be using a calculator on your phone, or you might be using a calculator on a Chromebook or on a computer or something like that. That's fine as long as it's scientific. It's more than just add, subtract, multiply, divide. You got more buttons to it. When you look at that calculator, you're going to see one of a few examples of the button I'm looking for. On most TI calculators, it's labeled EE. On most Casio calculators, it's labeled EXP. If you look on a calculator, let's say on the computer or on your phone, it might be labeled as one of those two things. You also sometimes may even see it labeled as times 10 to the n. Right? Whatever, there is a special button. And that special button stands for times and 10 and an exponent of some kind. Okay? So all three of those are all taken care of right there with that one button. In fact, if you try to hit times 10 to the power of instead of that button, most calculators won't give you the right answer. So you need to learn about that button. That's really important. So you never enter the times and the 10 and the n part. Either the EE or EXP button, or sometimes it's even labeled as times 10 to the n, is what you're going to use. So, for example, here's a common number that we're going to find next semester that we use a lot in chemistry. It's a really famous number in chemistry. But for now, let's just take that number and try to enter it in on whatever calculator you're using. So it's 6.02 times 10 to the 23rd power. It's a ridiculously huge number, but it actually is really important for us later on. So if you wanted to use that on your calculator and you had to enter that in, I want you to be able to enter that in the correct way so you get it right. So you would hit the 6, the point, the 0, the 2, and then you would take that special button, whatever that special button is, EE, EXP, sometimes maybe it's even this over here, whatever it is, 6.02, special button, and then 23. You don't hit times, you don't hit 10, you don't hit to the power 2, you don't hit anything else. 6.02, special button 23. Right? And then your calculator may show that on its screen in a weird way. Some calculators may show you, once you've entered that in the calculator, on the screen of the calculator, it may show it to you like this. It may show it to you like this. Some calculators don't even have a symbol on their screen. It just shows you with a blank between them. And then some calculators are kind of fancy. They may even have a little symbol on their screen, a little times 10 to the, and then show it to you that way. They all mean the same thing. You just have to get used to it the way it looks on your calculator because, again, you will be using this part of your calculator quite often. Nobody wants to work with these kind of numbers by hand. So then you can take that and then you can subtract or add or multiply or divide any of those kinds of numbers. Scientific notation numbers, non-scientific notation numbers. It doesn't matter what kind of numbers you use on your calculator once you know how to use that special button. In fact, there is going to be a rule in this class. It is a rule for this class. It is not found in your book. It is not found anywhere else, but it is a rule in this class only. If the original number of whatever answer you're coming up with turns out to be bigger than 1,000 or less than 1,000th, you must write that number in scientific notation. Okay, that's the rule. I don't want people coming up with an answer on their problem and saying, oh yeah, the answer is 20 million. Oh, I'm really sorry about that, 0. That was really bad. That was my slip of my hand there. So normally you'd have to write 20 million like this. Okay, that's ridiculous. I don't want to see all those zeros. You don't want to write all those zeros. 20 million should be written the correct way, which is 2 times 10 to the 7th, because there's 7 of those places I had to move the decimal point over before I got to the 2. Okay? All right, so that's the first part, and then the next part we'll go through some things about the actual precision and accuracy of measurements.